So with a brand new document, there are going to be our standard 2 functions or methods that we add to every document. So these functions we will use repeatedly, and that's going to be a little bit of review before we talk about some of the newer stuff. So we still always have our void setup, and then there will be void draw. Now you'll notice I did my open curly brace, I hit return twice, and then I put in my closing curly brace, and then I can hit an up arrow to start typing my code. The reason for wanting to do that is because that prevents me from forgetting to put in my closing curly brace, which will cause your program to crash. So every time you type an open parenthesis or open curly brace, make sure you get that closing one in as soon as possible afterward, and that will save you hours and hours and hours and hours and hours and hours of grief. So I can't stress that enough. If you forget to put in your curly brace to close it, it will break your project over time. So once we have that, one of the other things we will probably always want to do is specify our size. So I will say 800, 600. Remember that white space, so extra spaces, lack of spaces, that's all, it doesn't matter. But capitalization does matter. So I didn't put a space after the comma. I can. Doesn't hurt things. It may or may not make it more readable depending on how, when you look at it for you personally. But if I put a capital S on size, we'll also see it's no longer blue. I'm getting error message at the bottom. So it's important for me to say it correctly. Once we have our core project set up, I can test it and hit run. That's Command R, or I can hit the play button. Both will serve the same purpose. And now I know that it is working. It's a good idea to save consistently and regularly while you are working. I save before I type a single line of code. I feel that's very important. It's also important as if I'm going to ask you to put your name in your code, it's important for me to do so as well. And then I just put a description, and I can put in the date of, it's something along the lines of, putting in the extra space, the extra lines just helps with legibility. You don't need it, but I find there's no harm in putting in extra line returns because it organizes your code. Eventually, you want your code to be neat and readable, because when we start writing programs that are 500 lines long or longer, if you haven't taken steps to try and make it readable, it becomes very difficult to slog through it. So it's important for you to get in that practice now. Now the next thing that I'm going to do is I am going to set up some variables to use in my program. Now variables are one of those programming constructs, and they carry across pretty much every programming language. And what they are is a way to reference something without having to know exactly what its value is. So I can make a reference to the position of an object. So I can make a variable and say, I want to know what is your x position. And I don't have to then keep track of that number personally, because I now have a reference to it so that I can then use that value inside my code. And when we are programming visual objects on screen, we will often make a reference to that object's x, y, and sometimes z, if it's a three-dimensional space, coordinates. So we know where is it located on screen. So what is its x, what is its y, and then z if it's three-dimensional, and then we will often make a reference to, say, how big something is. So we'll want to know what is the height and width of that object. And if we store these values, we can then control them through code much easier. Now, one thing about processing and the language it is derived from, which is Java, is that the variables we're using, we have to tell the coding environment what kind of variable it is, what type of number, or what type of letter, what type of object. It wants to know so that it can then take a chunk of its memory and set it aside and reserve it for that kind of data. Because each kind of data takes up a different amount of memory inside the computer. So a number takes up a different amount of memory than a word. And a word will take up a different amount of memory than a picture. So all of these things take up different kinds and quantities of memory. So our programming environment needs to know that so it knows how to use its resources properly. So that's why we have to specify those things when we start typing it in. So if I am trying to keep track of the position of something, I may reference it as a number. And there are two references to numbers that we will commonly use. One will be float. And I'm just making up a junk variable right here. So my floating number, and then I can assign a value to it. And I could assign a value of, say, 4.9768456. So what a float is it's a number with a decimal point and possibly values after it. It could also be 4.0. If I rounded this up, it would be 5. So really it'd be, we'd round up and you could say it's 5. And if I have an integer as a number, then that one can only be 4. So when we're creating a variable that is an integer, it can only be a whole number. It does not get anything after a decimal point. That's the distinction between a float and an int. And the reason that we need to be aware of both is certain methods within processing that we will send values to and make the program do things. We'll be expecting sometimes a float, sometimes an int. So we need to just be aware that at times we will need to use one versus the other, and we can convert one into the other. So we have a conversion function that we can apply to them, but we have to know that they're both valid ways to reference a number. If I don't have a reason otherwise, I usually do all my numbers as floats. Now, after float and int, then what we are going to be working with as well is we may be working with a string. String will be slightly different. A string references letters, plural. We have character, which we can reference an individual letter. But typically, when we're working with letters in our coding, we're doing it as parts of words. So we use string. You may notice one thing different here. Generally, when we're declaring a type for a variable or something else, it's almost always going to be a lowercase value. But string is an uppercase because string is not a primitive data type, but it is a class composed of characters. So the character data type that string holds together would be a lowercase c. But string, because it's a class that works with characters, multiple characters, or even a single one, because it's a class, classes by convention are capitalized. So string gets a cap where int and float do not. And if that's more information than you want to just accept that if you're creating a variable for letters, it's string with a capital S. When you're working with numbers, it will be int and float. And these three data types are the most common you will use. There's one more that we may or may not dig into this afternoon, and that is Boolean. Now, Boolean it does not deal with ghosts. It took me 3 tries to remember how to capitalize it in processing here. But Boolean is a value that can have one of two results, true or false. So think of it like a light switch. The light is on or the light is off. There's no in between. We don't have a dimmer switch. It's not a programmable multi-color light changing ambient LED light. It's just a standard incandescent light bulb. It's on, it's off, nothing else. So a Boolean is on or off. It has two values, true and false. And we use those because often when we are doing our coding, we will be asking the computer a question. But the computer can really only answer us with one of two values because the computer thinks in black and white, on or off, true or false, ones and zeros at its default. That's how computers work. Is at their simplest operation, a computer is either true or false. All of the, in effect, transistors on the microchip that are controlling your computer break down to it's a whole series of yes and no, true, false questions. That's what's at work inside the machine. It's just millions of them. So we're now asking the computer constantly, we'll be asking the question, is some situation true or false? And depending on the answer to that determines the outcome. And we will be going through the asking of the question, but we won't specifically be using a Boolean variable probably today. Maybe, maybe not. I will be referencing these 4 values a little bit later. I'm just going to comment them out because I don't really care about them at the moment. But what I am going to do is I am going to create 4 new variables.
Any comment on that?
So float x, float y, float w, float h. So what I have done is I have created 4 variables. X, y to reference location, WH to be the size of my object, the width and its height. Inside my setup, I am going to then give those values. Now we'll say x is equal to 200. Y is equal to 300. W is equal to 50. H is equal to 75. It's a good practice to define your variables. And then you give them values instead of doing it in one line. Now, because technically I could have said float x is equal to 200. I could have done that. But if we get in the practice of doing it this way, it's going to set us up for more complex projects down the road without having to change how we do things. So it's a good practice to get into is to define them that way. Now, I'm just going to create a fill color of red. I'm going to draw a rectangle at x, y, width, and height. So technically, when this happens and shows up on screen, we probably aren't going to see anything different. And I'm just going to put in a background color of white, just so It's not red on gray, because the red on gray is just a hard relationship to look at. So I've created 4 variables, x, y, width, height. I've set up my project at 800 by 600. I've given x, y, width, and height all values. Then inside my draw, I set my fill color, and I'm drawing that rectangle at x, y, width, and height. Now, if you think back to the homework that you worked on for this week, using mouse x and using mouse y really was kind of like using variables. But the values of those in the variable mouse x and the variable mouse y are already predefined in the language. That's why you didn't have to define them on your own. The program does that ahead of time so that you can get working sooner. So if I run my project, I'll come up and I'll see there's a red square. So technically, we're not seeing anything a whole lot different than what we saw before. But I'm going to make one modification here. And I'm going to say x is equal to x plus 1. And before we see the results of that, I'm just going to point out one thing. If, when you are typing, if you end up where lines of your program are all mishmashed and not lined up and it's all junky looking and not nicely formatted, under the Edit pull-down menu, you will see there is a command, Autoformat. Routinely, when I come to work with you on your code, one of the first things I will do is make you auto-format your code to clean it up so that I can read it. Because when you do that, it cleans up all your indents and gets it all nice and pretty. If you're anal retentive, that should just make you thrilled to death that you just learned that the program can clean up your formatting and have all your indents worked out. Because soon we are going to be putting curly braces inside of curly braces inside of curly braces. And that requires multiple levels of indent. And when we do that, if you don't line those up, we can't read your code. So now, if you've added in the x is equal to x plus 1 and run your project, you will see that we've now achieved animation with hands off. Looked at this, it ran off the screen, so our little box ran away. I'm going to speed it up just so I don't have to wait as long while it flies off screen. So the box is going, it's hitting the edge of the screen, and then it's still going. So if you could see, it's now way off the side of my monitor, nowhere to be seen ever again. And that's okay, but we do have the ability to bring it back. We have the technology. We have the power. And if we want to do this, what we need to do is we need to ask the computer a question. So what I want to have happen, and if you can put what you're trying to do in English, not in programming speak in English, it suddenly gets a lot easier to code. So I'm going to just write it out in English before we write out the code and say, if the box is at the right side of the screen, send the box back to the left. So I'm creating an asteroid style screen wrapping animation. So it's just going to keep looping itself across the screen. So it'll go across, hits the edge, goes back to the beginning, and it's just going to keep looping. Later on, we'll look at making it bounce. So when it hits the edge of the screen, it's going to bounce, and it will then bounce back and forth, ping pong style. But right now, we want to go with the asteroid screen wrap. So if the box is at the right side of the screen, send the box back to the left. So that's the English of what we're trying to do. If we can get our code in English first, figuring out then how to write it in code is a little bit easier. Now the boxes, what we're really caring about is the x value of the box. Not just the box itself, but we just care about its x value because that determines where that box is. So what I could say is, if x is at the right side then start back at the left. So what we're finding out is we need to use a conditional statement. And the format for a conditional is if, and then we put the conditional statement inside parentheses, and then we have curly braces of what we want to have happen. So we want to say is if x is greater than 800. 800 is the width of our project. We know that because we set it in the setup. But processing has a neat value that we can access the width of our project just by typing in the word width. We can also type in the word height, and that will give us the height of the project. In this case, it would be 600. So we can do that. We can't just use W because W represents the width of the box itself that's being animated. So I could potentially just put a comment in here and go box variables. So these are the box variables, x, y, width, and height. So if my x is greater than the width, what we really want to have happen is we want to start it back at the beginning. So then we can say x is equal to 0. And when I do that and watch it run, you'll see that it now creates the asteroid screen wrap. And that can be a decent way of working with it. Now if we wanted to appear to we want to create the illusion of it disappearing off screen for some length of time instead of 0, we could just as easily put in a negative number so it seems to disappear and then slowly come back on screen. So it goes off screen and it's gone for a little while. And if that's not long enough, we can do it. And it creates the illusion that things are kind of having some time to wrap themselves across the screen. And the timing part of it, of how long it should be gone, should it be gone at all, it really depends on the type of animation or interactive or game that you're producing for how you want to manage that type of thing. Is if we use x is equal to x minus 1, why that didn't work. And if we talk through what values are being generated, I think it will make a little bit more sense. So if I start at the edge, it still runs off and we don't get to see anything. But if we think about what's happening, so if the x is greater than the width, we take one away. And now we add one back. Then we check, are you greater than the width? Now it's greater than the width. We take one away. So let me just change this width. And I'm going to change that to 700. And we'll start at 600 here. This gives us a short little animation. And what we see is the box is stopped. Because if we calculate this, okay, we're greater than 700. We take one away, we're at 699. Okay, go to the box. Next line, x is now equal to x plus 1. So that means we're back to 701 when x is greater than 700. So we're at 701, this triggers. It takes one away. We're at 700. Now we add one back. We're back to 701. So we're caught in this perma loop of 700, 701, 700, 701, 700, 701. When it's at the edge of the screen, we never got to see that. It didn't bounce, but it didn't, it didn't come back, but it didn't keep going. It just parked, which is what we see on screen now. It's just stuck there. So that's why that didn't work. And it's useful when you are having issues with things that what you sometimes will do is you will tell the program to show you what is that value. So we ask the program, can you show me what that value is so that we can see it on screen? And we do have two ways that we can go about doing that. One is we can print out the value to what is called the console, this little section of black down at the bottom of the screen. The other way is we could actually draw the value using the text command on screen. That would be another way that I could go about doing that. So I am going to draw my x value on screen, and we'll draw it at 5,200. And we can see there it is, was down at 700. Now, so if we mark the original value, we'll see it's going up. That one hit 701, that's 700. And now each time it's 700, 701, but we can't see that redraw because they're now just generating the same number over and over and over and over and over and over and over. We're caught in that loop. So that's why that doesn't work. And that's why we're better off using, instead of that, if we put in our value of x is equal to 0, comment that out, and I'm going to speed it back up a little bit just so we can see our demonstration happen faster. Now you can see how that value is going, and it just keeps progressing by 5s and looping on screen. To add in the second element, so this time I want a box that is not looping, but instead will be bouncing. So it's going to need its own set of variables to go with it. So I'll say float x2, float y2, float w2, float h2. This will be my box 2 variables. So x2 is equal to 400, y2 is equal to 300, w is equal to 20, h is equal to 20. Now, with this, we're going to need something else. We're first going to start out with one value, and then we will progress from there. And let me just add in my missing 2's here. What our second object is going to need, it's going to need a speed x. Actually, we'll do a speed y since the other object is going horizontal. I'll make this one go vertical first. But you will eventually, and I will be leaving that to you, want to be incorporating a speed y or a speed x in addition to a speed y. But I'm not too worried about that yet. Speed y is equal to, I'm going to just choose 5, so it's going to be moving similar to the other box. So there is that. So this box needs a speed variable. The other one doesn't. It could have one, but it doesn't. So all of this first part here will be related to box 1 stuff. And now I'm going to go down here, box 2 stuff. I'll give this box a different fill. I'll just fill it with blue. And we'll do a rect at x2, y2, w2, h2. Now, if I run the program to verify things are working, run often. Don't type in a ton of stuff and then hit run and watch it blow up because you don't know what broke. So before you add any new functionality, test your program. Always test it to make sure that it's mostly working. So now my blue box is working, but now I want it to start going up and down. So what I could say is I could say y2 is equal to y2 plus speed y. So instead of modifying the speed of my object by a hard number like I did 5, I'm modifying it by a variable. And that's going to be critical. So if I look here, oh, and now it fell off the world. It dropped into nothingness. To get the bounce in here so that it bounces up, what we need to do is figure out how do we add that bounce back in. And it's going to be pretty similar. So I can say if y2 is greater than height, return twice, closing curly, up arrow once. So if y2 is greater than height, this is where the magic trick happens. There's a magic programming animation or programming movement trick where what we do is we take that value and we say speed y is equal to speed y times -1. So we are using the magic of -1. So if you think about what that does, if you take a value and multiply it by -1, it inverts its positive or negative charge. So right now, speed y starts out at 5. So we fall down at a speed of 5. Then when we hit the bottom, we want to flip that. So we want to change our speed to be a negative value so it can start going back up. So if I run my program, now it bounces back up.
But then it disappears.
Problem that once it hits the ground and goes up, it never comes back down. So we do need to modify that. So what we could do is we could check for the situation of if y2 is less than 0, which is the top of the screen, speed y is equal to speed y times -1. Closing curly. Now, if we watch, what we will see is it now bounces. To add back last week's kind of fancy effect, I choose a fill color of 255, 100. That gives me transparent white. And then on top of that, then I will draw my rect at 0, 0, width, height. And then we get the little trail effect going on their objects. So once that is occurring, now we have that. So what we are wanting to see happen, and it seems there's been a feature request from people of, okay, well now it's moving up and down, how do we get some diagonal action going on? So if I have a speed x as well as a speed y, then I can move my object on both axes. And I'll just start them both out at 5. We have a speed x and we have a speed y. It's moving at 5 in both directions. Now, in the box itself, under the box 2 stuff, then we just say x2 is equal to x2 plus speed x. And we need separate x and y's because most of the time we will only hit one side at a time. We won't hit directly perfectly in a corner. If we hit a corner, then we would be changing both our x and y values. But because we're not, we need to redo it. Now if I watch this, we'll see that it went diagonally and now it bounced once and went off screen. It bounced on the bottom. But if we think about what's happening, when I go down, I'm hitting the bottom. So I want to change my y to go back up. But even if I'm going at an angle, I don't need to change my X and invert that, so I bounce back, but instead I want to bounce back at an angle. Now if I hit the side over here, that's an X, so speed X, we need to invert that. So then we need to do a check for the side, which is going to look very much like what we did on box 1. So if I say something like if x2 is greater than with, then speed x is equal to speed x times minus 1. So now when we bounce at the bottom, then we'll hit the side and now bounce back. But now when I hit the left side, it still goes off screen because we haven't accounted for that fourth wall. So this, if I put in a comment here, this will be bottom, check. This will be top, check. This will be right, check. And now we will do our final left check. If x2 is less than 0, speed x is equal to speed x times minus 1. And now we'll see we've hit 3, 4 sides. So now we can bounce off of the 4 sides. There are some niceties we could do here, so we could further clean it up so it never actually goes off screen, because you'll notice when it hits some of the walls, it's actually going partway off screen, and we don't really want that. So on the bottom and the right, so we could adjust that, but I'm going to leave it to you to look to some of these niceties and figure out how you might clean this up a little bit.